Good afternoon, students. This is a continuation to the last class. In the last class, we studied about what exactly the telemetry system and data transmission methods which we are using, depending on the variables which we are using and the distance, how long we are supposed to send the information. Depending on that, there are three different types of data transmission methods. One is the hydraulic data transmission, which we have seen in the last class. One is hydraulic data transmission. Another one is a pneumatic transmission, another one is the electrical and electronic transmission. So in the present case, we are going to study about the what is that electrical and electronic transmission. We are using the electrical and electronic transmission. Okay, wait, electrical and electronic transmission. Okay. So electrical and electronic transmission means in the electrical and electronic transmission, we are sending the information in terms of the electrical signals like voltage, current, pressure, voltage, current, frequency, position, and impulse responses. Means using the impulse signals also we are sending the information. So here, depending on the transmission media, means in the electrical and electronic communication, the information is going to be transferred in the electrical signal format like frequency, voltage, current, position, as well as the pulse format. You can send the information. Okay, now. So that is what in the electrical and electronic telemetry system. So depending on the transmitting medium, whether it is a word or wireless medium, depending on that, the telemetry systems are divided into two types, which we have seen. I'm just revising those points. So here we are having the landline telemetry system. In the landline telemetry system, the communication path is a physical path. Physical path means we are using the word communication between the transmitter and the receiver. So that's why it is called as a landline telemetry system. The physical path may be any word communication like telephonic wire, or it may be the optical fiber, or it may be the simple power cables. We may use any kind of word communication path between the transmitter and the receiver. And another one, if at all we are not using the word communication, but we are going with the wireless communication. If we are going with the wireless communication, that telemetry system is called as a radio frequency telemetry system. That telemetry system is called as a radio frequency telemetry system. Now, in the first case, what we do is we will go for landline telemetry system. So landline telemetry system is further divided into, as you are seeing on the screen, the landline telemetry system is further divided into voltage telemetering system, current telemetering system, position telemetering system. So means these are the classification of our landline telemetry system. So the landline telemetry system is classified based on in which format we are sending the data. Means whatever the measured data we are having, whether the data is transferred using the voltage signal, or using the current signal, or using the the frequency, or using the pulse format. In which format we are sending, based on that, based on the electrical variables which we are using for sending the information, based on that, the landline telemetry system is further divided into voltage telemetering system, current telemetering system, position telemetering system. And the last one is a radio frequency, which we are going to study as we move on. So let us go for the voltage telemetry system. Okay, now. So what exactly the voltage telemetry system is a question. In the voltage telemetry system, we are sending the information from the transmitter to receiver using the communication path, but in terms of the voltage signals. Means the electrical signal, electrical variable which we are using in the transmission is a voltage. We are sending the information in terms of voltage from the transmitter to the receiver. We are sending the information in terms of the voltage from the transmitter to the receiver. Okay, from the transmitter to the receiver. So based on that, it is called as a voltage telemetering system. Means based on the variable in which format we are sending, it is called as a voltage telemetering system. We are sending information in the voltage format, so that is why it is called as a voltage telemetering system. Okay, so here in the voltage telemetry system, let us go for the this is a block diagram for the voltage telemetry system. So let us go for the individual blocks. So here we are using the battery along with the the potentiometer. Actually, this one is a potentiometer, and this potentiometer, another terminal is connected to one end, and which we call it as a sliding wire. And this one is connected in series with this particular potentiometer, and also a Bourdon tube. See, in this voltage telemetering system, I would like to measure the pressure. Actually, the main intention is I would like to measure one physical parameter, which is nothing but the pressure. So I would like to measure the pressure, and that should be transferred to the receiving end, that is nothing but the base station. That should be transferred to the base station. So that is the main intention of my voltage telemetry system, which I am using and displaying on this particular screen. So if you see this one, we are using the Bourdon tube in order to check the pressure, in order to measure the pressure, which is a physical entity, by the transducer. I'm using one of the transducer, which is nothing but the Bourdon tube. The main intention of the Bourdon tube is it is going to be senses or the measure the pressure experienced by this particular element in the environment. That information is converted into the electrical signal form. As we know that the information is going to, this particular Bourdon tube is connected to the sliding wire. Whenever there is a pressure change, within the surrounding of this particular Bourdon tube, that Bourdon tube takes, whenever there is a pressure change, at that time it takes the responsibility to change the position of this particular pointer on the potentiometer, so that there is a voltage deflection, means there is a voltage drop within this particular potentiometer is going to be changes, and that voltage drop, that voltage change is going to be transferred through the telemetering channel to the measuring device, which is nothing but the end device. So this is a the area where we are measuring. We are measuring the pressure using the Bourdon tube. Let me go for the end device. What we are having the end device. So in the end device, I am going to use one null balanced potentiometer, null balanced DC potentiometer, which measures the which is going to be receives the information in terms of voltage, and the received information which is there in terms of voltage, that is going to be converted back into the pressure format. We are expecting the measuring of pressure and displaying the information in the pressure format only, not in terms of the voltage. But between the transmitter and the displaying, the information is going to be transferred in terms of voltage. Okay, means here we are using the transducer, which will convert the physical information, which is the pressure, into the electrical signal, and the converted electrical signal will be transferred through the telemetering channel, and in the end device it is going to be receives the information in the electrical signal format only, but final display is going to be done in the pressure format only. That is nothing but the potentiometer, whatever the potentiometer which we are using right over here, that potentiometer is arranged, tuned in such a way that which is going to be displays the information in terms of the pressure, which is nothing but the kilo Newton per meter square. So kilo Newton per meter square. So this is the pressure scale. So means this particular potentiometer is tuned to the giving the pressure readings, So that is the main intention of the end device. Now let us go for the analysis. In the voltage telemetering system, as we have seen that we are interested to measure the pressure using the Bourdon tube. So the working of this particular telemetering system is from the transmitting terminal. What is happening in the transmitting terminal means the Bourdon tube is the one which is going to be senses the present pressure in the environment, which is experienced by this particular Bourdon tube. That information is going to be means using this particular pressure information, means which is converting the pressure into the electrical signal with the help of, means another end of the Bourdon tube is connected to the sliding wire, which is connected to the potentiometer, third terminal of the potentiometer. Whenever there is a pressure change, then obviously this element is going to be disturbs the sliding wire. So because of that, this sliding wire is connected to the potentiometer third terminal, and it is going to be move either in the upward direction or in the downward direction, depending on the pressure experienced by the Bourdon tube. So at that time, here as the wire is moving, at that time there is a voltage difference from the initial case. From the initial case, there is a voltage difference from the initial part. That voltage difference, deferred voltage is going to be transferred from the transmitting end to the receiving end using the telemetering channel in the form of the voltage. Using the telemeter channel in the form of the voltage. In the receiving end, we are using the again what is that null balanced potentiometer, which is going to be receives the information, means the null balanced potentiometer is adjusted in such a way that which is going to be displays the final readings on the screen in terms of the pressure only, which will measures the present of physical and electrical signal for transmitter from the transmitter, which is in the voltage format, which is going to be converted back into pressure format, because we are using the needle, and which is going to be shows the reading on the screen in terms of the pressure only, which is measured in the kilonewton per meter square. So this is what the receiving terminal. So simple case is, we are sending the information, physical information from the transmitter to the receiver in the electrical signal format using the telemetry channel. Here we are going to use two-wire communication. This particular two-wire communication, whatever the communication path, whatever the wire which we are using for telemetry channel, whatever the wire which we are using for telemetry channel, it should have the low resistance. And that resistance, the area of cross section of that particular wire should be uniform throughout the path from the transmitter to the receiver. If at all there is a change in the diameter, obviously, as we know that the resistance of the path is going to be changes. When there is a change in the resistance of the path, then obviously the voltage drop is going to be changes. When there is a change in the voltage drop, we can't expect the measured value, exact measured value at the destination. So that's why whatever the communication wire which we are using as a telemetry channel, that should be have the low resistance, and the diameter of that particular wire should be the uniform throughout the path. So because of that, what we are supposed to do means, whatever the path which we are using, whatever the wiring communication which we are using, in this case, that should be protected from the external disturbances. External disturbances means there is a socket. Again, we are going to use the socket to protect the wire from the external disturbances. Okay. And another case is where we can use this particular telemetry channel is a question. Voltage telemetry channel. The voltage telemetry channel can be used within the length of 300 meters, not more than 300 meters. Means the distance between the transmitter and receiver should not be greater than the 300 meters. Because as the distance is increasing, we are not sure that the resistance of the path is going to be uniform. The resistance of the path is going to be uniform. Means the area of cross section of the path is going to be uniform. If it is changing, obviously the resistance is going to be changes. Obviously, if the resistance is changing, obviously the voltage drop is going to be changes. So we are not sure that maintaining the area of cross section of the wire throughout the communication path is uniform. It is not possible. So that's why it is restricted to a particular length only, not beyond that particular length. Okay, it is one of the reasons why we are not using the voltage telemetry system for the long distances. Okay, because the communication path plays a major role. Because of that particular one, we are not allowing the telemetry system for the long distances. We are not using this kind of voltage telemetry system for the long distances. Okay. This is one of the advantage as well as the disadvantage. Advantage is nothing but we can simply use the wire communication from the transmitter to the receiver. And one more thing is, in the voltage telemetry system, it is expecting the low current transmission from here to here, from the transmitter to the receiver. When we are sending the information, we can't send the information in the voltage format only, but obviously there is a current which is transmitted along with the voltage. What is the current which we are transmitting along the voltage? It is not going to be in the high current ranges. It is in the small currents. Means a milliamperes of current is more than enough to transmit the information from the transmitter to the receiver. That's one of the advantages of using the voltage telemetry system. But the disadvantage is we can't send the information for the long distances, as there is a because of the restriction of the communication wire, because of the restriction of the communication wire, whatever the communication wire which we are using as a telemetry channel. The another method is called as a current telemetry system. In the current telemetry system, we are sending the information in terms of the current. We are sending the information in terms of the current, not in terms of the voltage. Okay. The basic telemetry system, the basic current telemetry system which is used in the olden days is like this. In this case, again, same scenario. We are using the board and tube. We are using the sliding wire, which is a potentiometer. Depending on this particular sliding wire, the voltage drop is going to be changes. Obviously, when the voltage drop is changing, current is also going to be changes. And this information is going to be transferred through the telemetry channel, to the end device. In the end device, I am going to use a milliammeter because the information is going to be transferred in the current format. Because of that, I am using the milliammeter. So the milliammeter is adjusted in such a way that it is going to be shows the readings in terms of the pressure, not in terms of the current. Obviously, it is receiving the current only, the information in the current format only, but final display is tuned in such a way that the reading is going to be shown in the pressure format, which is nothing but the kilonewton per meter square. Kilonewton per meter square. So this is a what is the basic telemetry system. But as technology is improved, the basic current telemetry system is further divided into two types. One is the motion balance, another one is the force balance current telemetry system. One is the motion balance current telemetry system, another one is the force balancing current telemetry system. Let us go for defining the what is that motion balance current telemetry system. In the motion balance current telemetry system, what we are doing is we are interested to measure the position of the element. We are interested to measure the position of the element and display that information, means how long it is moved, how far it is moved from the reference position to the another point, means from the reference point how length it is moved, from the reference point how length it is moved to measure and display that information. We are using the what is that motion balance current telemetry system. In order to check out the position of an element, as we know that we are using the LVDT, linear variable differential transformer. So this particular LVDT is the best example, best transducer which converts the displacement values into the electrical signal. So we already discussed about how exactly the LVDT is working, but if you want to know a little bit more about the LVDT, so this is what we are having. So in the LVDT, wait. So we're in the discussion of the motion balance current telemetry system. In that, what we have done is we used the LVDT concept. Yeah, this is what. Here we are using the LVDT now. So if you want to check it out, how the LVDT is converting the displacement value, the length, the position value into the electrical signal. We have seen this explanation. So this is my core, which is a freely movable one, and these two are the secondary wires, and this is the primary one. So let me show you the scenario. Two primaries, one primary, two secondaries. So LVDT, in the LVDT, we are having the one primary coil and two secondary coils which are connected in opposite series connection. So here we are using the two secondary wires, one primary connection. Depending on the core position, the number of flux which is linked from the primary coil to the secondary coil is going to be changed. Secondary coil, that too, we are having the two secondaries. So here we are having the secondary coil 1, secondary coil 2. So it is a primary coil. If at all the primary coil is at the reference level, means the length of the core which is propagated into the secondary coil 1 and the length of the core which is propagated into the secondary coil 2 equal. So I am not having the slide, I am not having that particular slide, but at the reference level, this is going to be equally what induced into the secondary coil as well as the primary coil, secondary coil 1 as well as the primary coil 2, secondary coil 1 as well as the secondary coil 2. Because of that, number of flux linked with the secondary coil 1 as well as the secondary coil 2 equal and opposite. Because of that, the voltage drop is going to be 0. The voltage drop is going to be 0 when it is in the reference position. But when it is moved to the left side, then obviously the position is going to be, means the number of flux linked with the secondary coil 1 is going to be increases compared to the secondary coil 2. So it is going to be shows the information that the LVDT is moved to the left side. If I'm assuming that the secondary coil 1 is a left side and the secondary coil 2 is a right side of the reference position, then obviously if as the core is moving to the secondary coil 1, I can say that from the reference position the object is moved to the left side. So I'm going with the another one. If at all the second core is moved to the right side, then the secondary coil 2 is number of flux linked with the linked from the primary coil 1, primary coil to the secondary coil 2 is going to be the more. So obviously the voltage is going to be the other way. So if you want, you can see in the signal format also. So here we are having the primary, it is the secondary, more signal, okay, which is in phase with the primary, and the green one is the secondary coil 2. So we don't have any secondary coil. We don't have any signal in the secondary coil in the because of the magnetic flux. So output is going to be the this one. Secondary coil 2 is nothing but the second output. So sorry, secondary coil 1 is nothing but this one, blue color one, which is going to be the output. Now another case is here. In this case, the core is moved to the right side from the reference position. So obviously we are getting the information. Means it is the opposite to the reference, opposite to the left side. So because of that, we are going to have the 180 out of phase with respect to the reference signal. Reference signal is nothing but the primary signal. With respect to the reference signal, the green color signal is a 180 degrees out of phase. So because of that, I can easily comment that the object is moved to the right side from the reference position, and whatever the output we are getting from the secondary coil 2, that is going to be displayed as an output. Okay, so this is the main intention of LVDT. LVDT is nothing but linear variable differential transformer, which is going to be senses. Wait a minute. Yeah, which is going to be transfers the displacement value into the electrical signal format. So this concept we have seen already, but I would like to review that one once. So using the same concept, we are using the motion balance current telemetry system. Motion balance current telemetry system. That motion balance is going to be done by the LVDT. So I would like here, what is our intention? Again, we are using the Bourdon tube to measure the pressure only, but the Bourdon tube, one end of the Bourdon tube means depending on the pressure, which is the depending on the pressure change in the environment, obviously the Bourdon tube is going to be react. So one end of the Bourdon tube is connected to the LVDT. Whenever there is a change in the pressure, obviously the Bourdon tube is going to be moved, and based on that, this particular movement, the Bourdon tube movement, is going to be affects the LVDT core. So this particular Bourdon tube is connected to the core of the LVDT. Obviously the core of the LVDT is either moving to the downward or to the upward direction depending on the Bourdon tube motion. Okay, so whatever the information which is sensed by the Bourdon tube is given as an input to the LVDT. So this LVDT takes a responsibility to convert the physical information into the electrical signal format, that is in the current format, and this current this particular LVDT output is in the, it is a transducer. Now LVDT is one kind of transducer which transfers the physical entity into the electrical one. So that is a very low signal, low intensity signal, but we are supposed to amplify that one to the required level. Because of that, I am using the amplifier. I am using the amplifier, which is the current amplifier, and sending the information from here to here in the current format. The information is going to be transferred in the electrical signal format, which is nothing but the current format, from the transmitter to the receiver. In the receiving end, again I am using the, as I said previously, we are using the milliammeter. That milliammeter is adjusted in such a way that which is going to be shows the readings in terms of the pressure, which is nothing but kilonewton per meter square. Kilonewton per meter square. This is a motion balance current telemetry system. And another case is what is that another one? Force balance current telemetry system. We have seen the motion balance current telemetry system, and another case is the motion balance current telemetry system. In the motion balance current telemetry system, I am going to use this kind of setup. So here, this terminal end device setup is not changing; it is going to be the constant, but only the transmitting end is going to be changes. Here, I am going to use one element which is going to be get rotated because of there is a variation in the Bourdon tube. There is a variation in the variation coming from the Bourdon tube. Means whenever there is a change in the pressure, then that change is going to be converted. That change is going to be transferred to this particular block. This block is a rotatable block. So this block is a rotatable block. Whenever there is a change in the pressure, the Bourdon tube is going to be moved. Based on this motion, this particular block is going to be rotated. So depending on this rotation, the number of magnetic flux linked with the linked from the primary coil to the secondary coil is going to be changes. Magnetic flux, number of magnetic flux linked from the primary coil to the secondary coil is going to be changes. It is just because of the motion of this particular block, and this motion purely depends on the Bourdon tube. Whenever there is a pressure change, obviously the Bourdon tube takes a responsibility to move this particular element, and this particular element get rotated in such a because of that rotation, the number of magnetic flux linked from the primary coil to the secondary coil is going to be changes. Okay, so it is going to be changing. So that change is going to be taken as a measured value, and that information is going to be transferred in terms of the current to the receiving end. Again, we are using the milliammeter that is going to be calibrated to show the information. Arranged means this ammeter is arranged in such a way that to show the information in terms of the pressure format, But the tricky from the motion balance current telemetering system to the force balance current telemetering system. In the motion balance telemetry system, we are not having the feedback element, but in the current balance telemetering system, we are having the feedback element. Means a part of the current which is driven is going to be taken back. It is going to be taken back, and which is connected to who? Connected to the block, which is rotating based on the Bourdon tube changes. Whenever there is a change in the pressure, obviously Bourdon tube is changing. Because of that, this particular block is going to get rotated. So as it is getting rotation, the magnetic flux linked from the primary coil to the secondary coil is going to be changes. So this is all about our force balance current telemetering system. So in the landline telemetering system, we are having the three types of telemetering systems depending on in which format we are sending the information, using which parameter, which variable, which electrical variable we are sending the information. Based on that, landline telemetry system is further divided into voltage telemetry system, current telemetry system, and the position telemetry system. So right now we have done with the voltage telemetry system as well as the current telemetry system. In the next class, we are going to study about the position telemetry system, and after that radio frequency telemetry system. So that's all for now. If you are having any doubts, you can ask me your questions in the WhatsApp group. Okay, thank you.